Let's talk about the remainder theorem. The remainder theorem says if a polynomial f of x is divided by x minus k, the remainder is f of k. So first let's talk about what that means, and then we'll talk about why it's true. Okay, so here's the what. It says that if we take a polynomial and divide it by x minus k, so there's sort of two ways to write that. Sometimes people write it like that in terms of division. And sometimes what people do is they write f of x equals x minus k times some other piece, maybe we'd say g of x, plus the remainder. So you could think about that as something like, hey, 81 divided by 4, and we could figure out what the remainder is. Or often we'd write 81 equals 4 times 20 plus 1, and that's where our remainder is kicking around. So what this says is it says if you want to know this remainder, just plug that k value into the function, okay? Conversely, if you want to know this f of k, you can just find the remainder. So let's just take a really simple example and see what that looks like. Let's say f of x equals 2x squared minus 3x plus 4. And let's say, what would happen if I divided that by x plus 2? Well, I'm going to get some term here, right? And I'm going to get some remainder here. Now, one way to do that would be to do synthetic division. I could take the coefficients here, 2, negative 3, and 4. I'd put in a negative 2 out front. Remember, I carry that down, multiply by negative 2, carry down, multiply by negative 2, carry down. That's my remainder. So this is an 18. And then this should be 2x minus 7. Okay, what the remainder theorem says is, you know, if you just needed that 18, you could have calculated f of negative 2. Let's see what happens. F of negative 2. 2 times negative 2 squared, that's 8, plus negative 3 times negative 2, that's 6, plus 4, that's 18. Go figure. So why is this true? That's the what. What about the why? Well, notice that in general, if you take a polynomial and you divide by x minus k, like we said here, you're going to get some polynomial out plus a remainder. That's a constant. Now the constant could be 0, could be non-zero, but that's what you're going to get every single time. What happens if you plug in k as the input for f of x? Well, you know that if you plug something in as the input on the left side, you're allowed to plug it in everywhere it appears on the right side. So that gives us k minus k times g of k plus r. I know k minus k is 0. 0 times this number that I don't know is still 0. So I get 0 plus r, or you can see I get f of k always equals r, the remainder. So that's why it's true. I just have one quick example here to show you how you might use the remainder theorem. Apply the remainder theorem to find f of 3, where here's your polynomial. Okay? So what are we going to do? I'm going to use synthetic division with these coefficients. I'm going to divide by 3. And so what I get out, I carry that down. 2 multiply 3 times 2, 6. Add down 3. Multiply 3 times 3, 9. Add down 10. Multiply by 3, 30. Add down 25. multiply by 3, 75, and my remainder is 85. The remainder theorem says f of 3 is 85, and I'm all done.